For the first minute, let's focus on what made Viking settlements possible in some of the harshest climates in Europe. Their farms weren't tucked into sheltered valleys. Many stood exposed on windswept coastal plains, battered by relentless storms roaring off the North Atlantic. Anyone who has walked those coasts knows the wind doesn't simply blow, it punishes. Yet the sagas rarely describe homes collapsing or livestock freezing. That silence is part of the real story. The Vikings solved wind management long before the engineering vocabulary for it existed. Archaeologists studying sites across Norway, Iceland and the Faroes eventually realized that something subtle but brilliant was happening outside the longhouses, a design choice that blocked wind, redirected airflow, and preserved heat so effectively that it held up for centuries. This wasn't guesswork, it was deliberate. And for survivalists today, it is one of the most practical ancient techniques you can learn. The Viking wind-blocking wall design started with a problem modern builders underestimate. In Viking territories, the biggest threat to a home's stability wasn't snowfall or even cold. It was horizontal wind pressure. Long, low-profile houses helped reduce force, but the real innovation occurred outside the structures. Excavations at sites like Lance aux Meadows, Borg in Lofoten, and various Icelandic farmsteads revealed low walls of turf, stone, or stacked brush placed at strategic distances from the main dwelling. For years, these were dismissed as livestock pens or random debris boundaries, but airflow studies and soil patterning eventually proved they formed intentional wind traps. Unlike modern windbreaks designed to block wind outright, Viking barriers redirected it. The walls disrupted velocity before the air struck the house, forcing the wind to rise and lose energy. This prevented uplift, reduced pressure on the roof, and kept smoke vents functioning. These walls were not decorative, and they were not improvised. They followed consistent patterns, height between waist and chest level, set several steps from the structure, and positioned on the side facing prevailing winds. They were carefully maintained, packed tightly, and in many cases extended seasonally depending on storm cycles. The strength of the design came from the way Vikings used layers to control airflow. A single wall alone couldn't tame Atlantic storms, so Viking builders created a layered barrier zone. First came a dense wall of turf or stone that acted as a primary buffer. Outside of that, many sites show remnants of brush fencing or woven branches, forming a semi-permeable outer shell. Instead of trying to resist the full force of the wind, this layered approach slowed it down in stages. By the time the wind reached the longhouse, it no longer had the force to lift thatch or push smoke back through interior vents. This technique still works. Modern fluid dynamics confirms that a porous first barrier dissipates wind stress more effectively than a solid wall. The Vikings achieved this instinctively through centuries of observation. They watched how snow drifted behind bushes, how wind bent grasses around boulders, and how airflow changed when cattle congregated near turf mounds. Their solution was not only functional, but durable. Turf walls held moisture and resisted rot. Brush fences, even when worn, could be replaced easily. The result was a maintenance-friendly wind system that protected the home for decades. The design's durability made it essential for livestock survival as well as human comfort. You know, the longhouse wasn't only a family dwelling, it often sheltered animals during the brutal winters. A poorly protected structure meant heat loss, draft exposure, and reduced smoke retention, all dangerous for both humans and livestock. The wind-blocking walls ensured that warmth generated inside the house stayed inside. They prevented sudden gusts from entering through minor gaps and reduced the chilling effect on exterior walls. Archaeological soil analysis shows reduced erosion behind these walls, confirming they reduced direct wind force. Many Viking farmsteads had secondary wind walls forming enclosed yards where animals could feed or rest outside without full exposure. This made winter chores safer and more efficient. It also kept food stores, drying fish racks and tool areas from being damaged by the wind. These weren't afterthoughts. They were part of the overall settlement strategy, integrating human shelter, animal management and environmental control into one system. This ancient technique offers practical, step-by-step benefits for today's homesteader or survivalist. The value of the Viking method is that it requires no advanced tools, no modern materials, and no expensive construction. Anyone can apply it using natural resources found on almost any property. The process begins by identifying the prevailing wind direction, something you can confirm simply by observing tree-lean, consistent snowdrift directions, or the way smoke travels from a fire on calm versus breezy days. Once established, the next step is building a primary barrier at a distance equal to roughly half the height of your structure. The wall should not be higher than your chest. Turf blocks, stacked firewood, stones or thick brush all work. The second layer involves creating a semi-permeable barrier several steps beyond the primary wall. Branch weavings, dried hedge cuttings or saplings set in the ground replicate what Vikings used. The outer layer breaks the wind. The inner wall slows it further and channels it upward. Leave a slight curve at the ends rather than abrupt stops. The curve helps guide wind around rather than forcing it into a dead-end collision. If you apply this design around a cabin, workshop, greenhouse, or even a tent, you will notice immediate differences. Heat retention improves. Smoke flows more consistently. Downdrafts decrease. Even the sound of wind changes, becoming muted rather than forceful. The forgotten Viking wind-blocking wall rewards those who study and apply old-world resilience. This is one of those rare historical techniques that doesn't require you to replicate Viking architecture. It simply requires you to understand their logic. They studied the environment, respected its power, and worked with it instead of against it. Whether you're an off-grid homesteader, a camper who faces harsh winds, or a history enthusiast seeking practical ancestral skills, this design has real, repeatable value. If you enjoy uncovering powerful ancient knowledge and want more history-backed survival techniques, make sure you subscribe to In the Beginning. Share this video with others who appreciate real historical engineering and keep this old wisdom alive.